All right, you honorable students. What do you think? What do you know? How are you feeling? What are we at? We got we're here in May and May 22nd when we're ending. What do you think? What do you like? What do you know? Is it going well? Are you enjoying this? We're partway through this geometry section. Do you feel like you're understanding things? Are things making sense to you? I hope so. If not, shoot me an email. Today's assignment you'll find might be a little easier, I believe, than some of the previous ones we've done. We've done quadrilaterals, we've done scale drawings, blowing things up and shrinking them in size, quadrilaterals, triangles. It's like we're moving backwards. Now we're only going to do angles. We're just going to be talking about angles today. So hopefully in going through this concept, it'll make sense. You'll understand what we're doing. And I'll be able to explain it in a way that makes sense. So enough talking, a little more doing. If you'll look on page 435, and take a look at questions A, B, and C for a second after I maybe show you. Imagine these skis are like straight lines, and they've got angles 1, 2, 3, and 4 listed on these skis. Imagine if he moves this skis a little bit. Imagine, let's say that he moves it so it's more of a 2 right angles. Let's say, or maybe he moves this one. What if he moves, using his feet, he moves those skis, what's going to be happening? That's a general concept for this page. List all the pairs of angles that share a ray. This is a ray right here. This right here. This half ski has got a starting point and an arrow. So for example, what shares this ray? Well, 1 and 2 shares the rays. And what shares this ray right here? 1 and 4 shares the rays. And this ray, a ray is like half a line. This ray, what shares this one? Well, 3 and 40. That's the beginning of what they're trying to have you learn as you go through these. You can go through these on your own. You can hit pause for a second and give those a shot. I'm not going to spend too much time on that, but that's the kind of relationships between angles that we're going to talk about today that will allow you to solve problems. Okay, you can look at that if you'd like, while I have to take some notes. Move it out of the way completely. Okay. In the discussion of angles today, there's some things you need to know, so I'll get some notes out, get a piece of paper ready so that you can write this down and you can always look at this note while you're going through the work. First of all, vertical angles, or sometimes call them opposite angles. That means if you have an angle like they've got a line like this and a line like that, vertical or opposite angles would be, let's say, this one and this one. They're opposite from each other, where this vertex is for all these where all these rays come shooting out. So opposites are sometimes called vertical. Let's say this one right here, so that one's C, and this one D. These lines are just to denote that these two are equal. When an angle is on the opposite side of this vertex, or they're vertical to each other, they're equal. So A and B is equal to each other, and C and D are equal to each other. Okay, there's concept number 1. Here's the next concept. Adjacent angles. Adjacent, or it means next to. If you live adjacent to somebody, you live next to them. Adjacent just simply means that you're, I'm sure you can look up on Google and find another definition if you like. On that example I showed you before, let's do angle W, X, Y, and Z. And if I said which angles are adjacent to each other, well, it's the X. Which angle is adjacent to X? It's X and W are adjacent, and X and Y are adjacent. Both of these two are next. So let's use these two right here. X and Y. Those two are adjacent to each other. They're next to them. Over here, W, X and W are next to each other. Now, sometimes these angles that are next to each other, Z, what angles are next to Z? What angles are adjacent to Z? You got Y, you got W. Sometimes when two angles are next to each other, they add up to 90 degrees. They're called complementary with an E. It's not like you're complimenting them, telling them something nice. It's a complementary with an E. They complement each other, just like friends complement each other. Not telling them they're nice, but complement means they work together for good. So a 90 degree, this little box means 90 degrees. Sometimes you'll have two angles. You'll have maybe this angle right there. We'll call it angle F. And you'll have another angle shares that ray, and maybe angle G. And you're told, you know what? Those two angles are complementary. They add up to 90. And then additionally, same type of concept with supplementary is if you could have two angles that are next to each other. Find a blank spot here that add up to 180. So you might have an angle here. You might have a line here. You might have an angle over here, X and Q, and you'll be told, you know what? Those two angles together add up to 180 degrees. That means that, let's say if this one is 150, then the other one will add up to the rest of 180. It would be 30. So the concept to be able to do today's assignment, to be able to do today's work, the things you need to know, the equations you're going to be asked to do is based on this information right here. There you have it. Push pause, write these down, write down these thoughts, these notes, this understanding that vertical or opposite angles are equal to each other, and that adjacent or next to angles could be complementary. They could add up to 90. They could add up to something completely, different. They could add up to, let's say, 100. But if they add up to 90, they're called complementary. And if they add up to 180, they're called supplementary. Pause now and write down these notes, and then come back. Okay, you are ready. You are ready for this. After I finish this M&M, back to 4:30 whatever. They then put you to work. They talk about two roads and what happens when they're intersecting in a way that's 20 degrees from 90. They're basically showing you two angles, and the angle of this angle is this amount, this angle is this amount, and they say, well, let's make them equal to each other and figure out what angle we get. And using the angle that we get, we'll be able to find out whether or not they're skewed, is what it's called. Skewed is if it's 20 degrees more than 90. We won't work it out, but you can see how they just put the opposite angles equal to each other and then solve it. On the try it on this page, though, here we go. These two angles there we go. MNQ, MNQ, and as we've talked about this before, it's the middle letter besides where that angle is. So MNQ up here, and PNR. So we go PNR are vertical angles. Well, vertical means they're opposite. It means that they're equal. We've learned. What's the value of X? Well, we know that those two angles are equal. Vertical angles are equal. So the equation, I can make this angle equal to that angle. I just said that this angle and these angles are equal, can be used to find X. Well, have you ever done an equation like that? Yes, you have. And there's some complicated ones like the one you see up here. There's some complicated ones coming your way, but it's just moving the numbers around the equal sign. So if I add 6 to both sides, trying to get this X, what's the value of X? Trying to get X all by itself. If you add 6 to both sides, 3X becomes 120. And if you divide both sides by 3, calculator if you need, X becomes 40. So X, the X value right here is 40. Why can you use an equation when solving for this? Because you know that they're equal. So take that equal sign, and the relationship that they have is put one angle on one side of the equal sign and one angle on the other side. Then they've given you these ideas, the complementary that we talked about, the supplementary that we talked about. Hey, if they add up to 180, then right here you can add them together and set them equal to 180 and then work through and solve it. if these two angles, 3x and 36, if they're complementary, if they add up to 90, then put the two measurements together in the sum and solve the equation. You can see how this equation understanding is really getting built in a problem like this, and you'll see these equation problems for the rest of your high school career. So this is good practice for what you'll be seeing 8th grade, 9th grade, and on into high school. So much so that you can even find the measure of an unknown angle if they give you certain understandings. This angle inside here is 2x plus 16. This one right here is 6x. They want you to find this one right here. And they've given you this little box here to tell you about the 90. So use the vertical angles to find the value of x is the first step. So you can set these two equal. 2x plus 16 is equal to 6x. And then once you've done that, you solve for x. X is 4. Using that information, if x is 4, so 2 x's or 2 4s, that's 8. 8 plus 16 is 24. So that angle in there is 24. And then you know from this box right here that these two adjacent angles are complementary. They add up to 90. So 24 plus something is 90. 24 plus something is 90. And that something is 66. Okay, to try it down here, if one angle is 4 times the other angle, so if the measure of angle 1 is 4 times the measure of angle 2, okay, and 1 and 2 are complementary, 1 and 3 are vertical, and 3 and 4 are separate, what are the measures of the 4 angles? You can even draw a picture if you need. Let's see. 1 and 2 are complementary, so the two of them add up to 90. You can see how my drawing doesn't work out very well. 1 plus 2. 1 plus 2 is 90. 1 and 3 are vertical, so 1 and 3 are across from each other. So 1 equals 3 because they're vertical. And 3 and 4 are supplementary. So 3 plus 4 add up to 180. What are the measures of the 4 angles? We could work through this problem. If 1 is equal to 3 and we put 3 in there, and we could work them out to, and the 1 is 4 times angle 2. So 1, that's the same as 4 times angle 2. We can replace angles in there. I don't want to take time on it because this is a pretty complicated problem. You can put the numbers in place of the numbers that we have and solve for each one. For example, if the measure of angle 1 is 4 times angle 2, in place of 1 here, you can put 4 times angle 2 plus another angle 2. So that means that 5 angle 2s is 90. And then you can work it through. Once you get that one, you can fill in the answers for the rest of it. I don't want to spend a lot of time because that would take a lot of work, and I'm already further into this video than I want to be. The information, the notes that I had are given to you somewhat here. They talk about adjacent, they talk about supplementary, they talk about vertical angles, and they talk about complement. So they're all here that you can look back to on your notes. Spend today working through these problems. I'm going to do a couple in just a minute, but I'll work through these problems and then check the answers in the answer key below this video assignment that you have. All right, the rest of the time is yours, and I'll just do a couple of them here. Watch the rest of this video only if you'd like. Okay, there's 2 pairs of adjacent angles. Well, you could do 2 and 3, you could do 2 and 1, you could do 1 and 5, 5 and 4, because they're adjacent. All the vertical ones, oh, geez, well, let's see. These right here are adjacent. Angle 1 and 3, 1 and 3 are adjacent. Now, what about these? This line doesn't go straight through, so I don't have any other adjacent angles. 4 plus 5 is the same as angle 2. but only 1 and 3 are vertical. If 1 and 3 are the same measure, so 1 and 3 are the same. So this 9x is the same as 90. What's the value of x? Well, if 9x is the same as 90, then we just solve the equation. So we're transitioning from the understanding that they're equal to, oh, how to solve an equation. Divide both sides by 9, x is 10. Do I want to do any of these other ones, or should I just have you check the answer key? I think I'll have you check an answer key. Well, in practice of writing the adjacent angles, MON, what is it adjacent to? MON, because you write O in the middle. This angle is next to which angle? Well, it's this one right here, LOM, LOM. And you have to write it in the right order with the angle point as the middle letter. That's the vertex of the angle, so you write it in the middle. That's one example. There's another pair you could also write. As I look through these, you've got the answer key. I think you're good. I think you've got a good understanding. I hope this has made sense with the items of right here. That's the information to know for today. And as a bit of a hint, the information you need to know for tomorrow as well. Have a wonderful day. Thanks for watching. Hope it's been a great 16 minutes for you. I've appreciated being with you. Bye-bye.